All right, so let's go back real quick and let's look. Please stop. Guys, don't. Number one, the first type of reaction we covered on Thursday was synthesis. What does synthesis mean? Okay, you take A and you take B and you make AB. Well, we're going to look at the opposite of that today. We're going to look at decomposition. What does decomposition mean? Exactly, right here it says to break down. Okay, so what we're going to do is we're going to take it, we're going to break it down into its similar compounds. There's two things that can be broken down into. The first thing it can be broken down into is its elements. Where will you get the elements from? The periodic table. The second thing it can be broken down into is its ions. What is an ion? Very good. It's charged. Where will you get the charges from? Reverse crisscross or the group number. Or if it's a polyatomic, you should have already had it memorized. Now, you're not going to see any ions in this case, but you will see a few other things. I'm going to forewarn you, decomposition is the hardest one to do. It is the hardest one. So what we're going to do is we're going to take AB, or AX in this case, and we're going to separate it into what? A plus X. And again, it can be in its elemental version or it can be into its ions. Number one, this is the one you need to know, and I'm telling you now, if you don't get it, you're going to be in big trouble. All carbonates will produce some type of carbon dioxide somehow. All carbonates, I would highlight that. Carbonates will break down into something in carbon dioxide. Now let's look at the example we have. All right, so I have Ca bonded to C bonded to 3 O's. Do you agree that that's kind of what that compound will look like? What does it say its two products are? What? Okay. All carbonates produce at least what? Do you agree that that will give me a CO2? All right, so that's going to give me a CO2. Now, what is left? Ca and O. But here's the deal. Is that a new compound? What must you always do with new compounds? Check your charges. Ca is in group 2, so it's a 2 plus. Oxygen's in group 16, so it's a 2 negative. So you're going to get CaO. Is that exactly what the products are? So legitimately, does it look like how it functions? What? What do you mean? Well, then you'll write it just like you've always written it.
So is that how you
just crisscross your charges.
Is that how you work it out?
Essentially, yeah. I'm just showing you schematically how it works. All right, let's look at the next one. Most. Listen, does that say all? No. Most metallic hydroxides, when heated, decompose into metallic oxide. So again, we have a metal hydroxide decomposes into metallic oxides and water. All right, look at that. Most metallic hydroxides, when heated, decompose into metallic oxides and water. What is the one exception? Group 1s. This is what I need you to put beside this. Yes.
I don't even understand what even these words even mean. Like, I don't know. I don't know anyone else.
All right, let's start over. Metallic hydroxides. What does that mean? It's a metal and a hydroxide. A metallic hydroxide. Means it breaks down into. That's what decompose means, to break up. All right? Decompose into a metallic oxide. Laura, that is a metal and an oxygen in a compound. And then, of course, you know what and water is. Okay? Now, this is what I need you to write besides except group 1 hydroxides. Group 1 hydroxides are called what? they're strong bases. Okay?
So is this the opposite of synthesis?
Exactly. It's the exact opposite. So you're taking a compound and you're breaking it up instead of putting them together. So it's essentially we can do the opposite of one. So I can take these two things and mix them and make that.
So we trying to like write the formula?
What you will have on the test is you will see this right here. And you will have to tell me what type of reaction this is. You will have to tell me the products and then balance it.
Are we going to practice something?
Absolutely. I'm not just, yeah, I wouldn't leave you hanging like that. Here's what I'm going to do. This is the pre-teaching to the worksheets. So when I give you the worksheets, you'll have all of this to look back at. Yes. Yeah. This class is a little behind, but we should be I will be finished with everything by Wednesday in the other classes. So I want to get through the whole thing by Wednesday. Huh? 100%. Okay? All right. So here's one other thing. I want you to know this. Group 1 hydroxides are strong bases, which means they turn into ions. Okay? So what does it mean? If we had this is what it would turn into. It'd be let me do group 1, sorry. It would be LiOH goes to Li plus OH negative. Read it one more time. Group 1 hydroxides. Do you agree that is a group 1 metal with a hydroxide? Okay. What does it turn into? What do ions mean? Where did that plus 1 come from? Lithium's group 1. What's hydroxide? OH minus.
Oh, so you have to put that in the equation?
Yes.
So
That's what it would decompose into. You will understand this more when I get to reaction type number 6. Okay? All right, but let's look at it from a different perspective.
can you use that to solve it?
Watch this.
How did you get that name?
It's a highlighter. All right. The formula that you had written to begin was CaOH2, right? Do you agree that this is Ca and 2 OH is stuck to it? All right. What was the first product that was formed? Okay. Ca what? Yeah. All right. CaO. Do you agree that's a brand new formula? What do you always do with new formulas? All right. So we have Ca2 plus O2 negative, right? So we have Ca and O. Yes, sir.
Does it matter if you take that O or
Doesn't matter either one. What is left?
H2O?
H2O.
That's what I'm asking. Can you use that?
Sure. Now, there's one little hiccup. You're going to see the very next one, but I'll show you how to deal with it. Yes, sir.
Could H2O come first?
Sure. It does not matter what order you write them in. As long as you have them labeled, like the compounds correct, it does not matter what order you put them in. As long as they're on the right side. These are products. You can't put them over here. Okay? All right, let's look at the next one. Now, the next one, and I told you that decomposition is the hardest one. Please note this. This is the hardest one right here. Metallic chlorates. Laura, do you agree that K is a metal and ClO3 is a chlorate? So any metal chlorate, any metal. Okay, notice, please, decompose into what? Metallic chlorides and, all right, please note that. Now, this one's kind of tricky, and here's why. How many metallic chlorides did they give you in this case? They gave you 2 of them. So watch what we do when we draw the schematic out. So we have K, Cl, do you agree that this is what it would look like? I have 2 of them. Where did the 2 come from? The 2 in front of it, right? The coefficient. Now, what are the products? All right, listen. 2 what? 2 KCl's. So you agree that I can take one here. Let's try this. So that one and that one. Do you agree that that's 2 KCl's? All right, so we have 2 KCl's. And then what's left? 3 what? So I have, now why is it not just O by itself? It's a diatomic. So I have 1 and I have 2. So I have 2 compounds and each one of them have an oxygen left over. So what can these 2 do? They can combine to form that plus 3O2. So does that make sense of schematically kind of how it works? Now, it's a schematic. It's a drawing. It's a visual representation. Schematic.
What is schematic?
It's a visual representation.
Schematic?
Google it.
How do you spell that?
SCHEM. SCHEMATIC. Shut up.
Or initial.
How do you spell it?
INTIAL.
SCHAM.
EM.
It's an I in front of the T. Initial.
What's it say?
He puts INTI.
It's I-N-I-T-I.
Schematic.
Yeah, I know.
Schematic diagram is a representation of the elements of a system using abstract graphic symbols.
But we're not graphic.
That was an exact perfect definition. Was that not perfect definition?
Just say it doesn't look good.
All right. Please listen. Guys, we got to keep going. Now, some acids, notice this. Some acids, when heated, decompose into nonmetallic oxides and water. Now, you do not have to know that one. Put an X beside that.
I put omitted.
4. Yes, you have to know 3.
So are we going to have to point out which is which?
4. Excuse me, number 5. Guys, y'all got to stop. Some oxides, when heated. Now notice it says oxides decompose to the elemental metal and O2. So if you take a metal with an oxygen and you try to separate it, notice what it separates into. It separates into just the metal and then oxygen gas. Now why is there a 2 there? It's a diatomic. Again, if you don't know your diatomics, it is going to kill you. I'm serious. It will destroy your grade if you don't get the diatomics right. Okay. And then the last one. The only one you have to know is example number 1. Notice what's happening here. What are you doing? Look at the first example. What's going on there? What is this?
H2O.
Which is? So we're taking water, and what are we doing to it? We are literally taking that H2O molecule and snapping it in half. Is that a chemical or a physical change?
Physical.
I'm breaking the H2 molecule in half. That is chemical. Now, does that happen by boiling? No. What did I have to do? You do need to know the definition of this. You will see this in the multiple choice part of the test. Some decomposition reactions are produced by electricity. This is called electrolysis. So what does the suffix lysis mean? To split or to break apart. So electrolysis is splitting by what process? Electricity. You do have to know this first one. Now, here's where your thinking has to come in. What is a gas inside of a liquid? A bubble. Who said that? Okay, a gas bubble. That's exactly right.
Ew.
Stop. All right. Listen. Guys, please stop. All right. A gas inside of a liquid is a bubble. If I were to take water and decompose it into hydrogen gas and oxygen gas, how could you tell which one was which? It's based on a mole-to-mole ratio. How could you tell? Because what I'm going to have to do, and I'm going to show you this one day. what I'm going to have to do is I'm going to have to take a petri dish, right? And I'm going to have an electrode in here and an electrode in here. This is a petri dish. Okay? And I'm going to have 2 wires attached to a battery. Okay? Do you agree that electricity would run through this? Okay? Here, bubbles are going to be produced. In here, bubbles are going to be produced. One side is going to be oxygen. One side is going to be hydrogen. So it's H2O goes to 2 H2s plus O2. Which side could you tell was hydrogen and which side could you tell was oxygen? No, I'm asking just by looking at it. Yeah, you can. For every 1 water, how many hydrogens are made? 2. For every 1 water, how many oxygens are made? 1. So how many would have more being produced? So for every 2 you'd count the bubbles. I mean, you could. It's obvious though, because it's making more. So it will be double the amount of hydrogen that would be oxygen.
So electricity.
You're separating it. Okay. All right. So now let's get into what I wanted to get into today, the real part. Single replacement. All right. Let's talk about the high school version of this, and then let's talk about the chemistry version. Yes, sir.
So we only need to know 1, 2, 3, and
5.
examples?
Yeah. No, 1, 2, 3, 5 in the first. You got to know 5 too. All right, so let's pretend that you're going to a dance, but you're going to the dance all by yourself. Stop. I don't need you any commentary. Now, you're going by yourself, but your goal before you leave this dance is to take somebody's date. That's your goal. All right. So, but here's the deal. Guys, when you walk in, you're going to find the girl that you want to dance with, but what's your number one problem? She's dancing with somebody else. So, girls, if a guy walks up and says, hey, I want to dance with you, what are you going to be comparing of the 2 guys?
Who's hotter?
Exactly. Who's hotter? You're exactly right. So, now, in chemistry, how do we know which element is hotter? Nice transition, but no.
Their temperature.
No, not literally. All right. The sheet that I just gave you. Everybody look at that half sheet I gave you. The top is the hottest element in the school. So this is who's hot, who's not. So lithium is the best thing around.
And gold.
So Matt is who on there?
I'm a U.
All right.
I'll be a good NA.
Jordan Belfort's LL.
All right, I don't know who that is. But
Leonardo.
please listen. All right. So gold is the least active. Lithium is the most active. So if lithium by itself walks up to a chemical compound with any other and trying to replace something, trying to get involved and swap, who can lithium replace? Anyone, because the top of the list is the best. So if it's above anything on that list, can it replace it? But what if it's below it? It will not replace it. Now, and I told you this when we first began, you drew a line down the center of that page. Can you cross over?
Yes.
No. Do not cross over. So this is what I want you to write. Please listen. Refer to the activity series for metals. Specifically, this is what I need you to write. Metals replace metals. Metals replace metals. So if you see that a metal is single right by itself and there is a couple that it's in a reaction with, a chemical bond or chemical compound, it's going to try to kick out one of them. Who is the metal going to try to replace? The metal. How will it, or how can it, if it's higher up on that list? Here's the great news. You can use this sheet on the test. Okay? Now, you will get a blank one, so it's not going to have any of your notes on it, but you still need to know how to utilize it. Okay, so you can write all over that, but you will get a blank one for test day. I'm not going to make you memorize this. All right, now, here's the opposite thing. Refer to the activity series for metals and nonmetals. Notice on the right-hand side, what are all of those? They're all halogens. Right above the word halogen, what group is that? Right above that, group 17. I need you to do me a favor. What is similar between that list and then the halogens on the periodic table? Notice the similarity between the list on that sheet and then they're in the exact same order. Very good. So the halogens are listed in the same order. So who is the most active halogen? Fluorine. Who's the least active? So can iodine replace any other halogen? No. Can fluorine replace any other one? Yes, it can replace all of them.
Basically, this is about electronegativity.
That's exactly right. No, you're exactly right. It's all based around electronegativity. Now, this is the other thing I need you to write. One last thing. Nonmetals replace what? Nonmetals, exactly. To me, single replacement reactions are the easiest. You just got to know how to do it. All right, so let's look at the examples that are given to us because there is some trickiness to it. You got to pay attention to the trickiness. Let's look at this first one. I'm going to box this first one up. All right, so who is by themselves coming to the dance in this first example? A. Who's the couple? BX. So A is going to try to get with B or X. Does it matter who it's going to try to get with? Yes, because metals only replace, well, the only way we can know is what element it is. It'd have to be listed. If it was a metal, you would know. If it's a non-metal, you'd know. But since it's already finished, who did A swap places with? B. Notice this. Now B is out by itself. So how can we tell if A was a metal or a non-metal? How can you tell? What? Yeah, but how did you know B was a metal? No. It could be a non-metal, exactly. So how did you know it was a metal? When is B written? B is written when? In the first. So since B is written first, it's a what? It's a cation, which means it's a metal. So that's what you need to recognize. Please note that when the thing it's replacing is first, it's got to be a metal. Now look at the other example. Who is coming to the dance alone in that example? Hang on one second, Hamza. Y. Over here, who did Y replace? X. But notice when X is written. When? It's second, so it's an anion, so it's a what? Non-metal. Now here's the deal. What are the only group of non-metal activity series that you have? Halogens. So that has to be two halogens. It has to be two halogens. Which one can it not be? Very good. Why? Because I can't replace anything. Laura, go ahead and ask again. You sure? Okay. Everybody with me so far? Juan, you with me? You sure? Because yeah. Yes, sir. It says metal and cation and anion and non-metal.
So, like, gold couldn't replace anything.
Exactly. Gold can't replace anything.
And let's say, whatever PT is. So PT can only replace gold.
Exactly. Exactly. All right, so let's try this. I'm going to ask you a few questions. Please don't answer this out loud. I'm going to ask you. Can magnesium replace cobalt? Don't say it out loud. Just think in your head. Can magnesium replace cobalt? Jack, what you think? Why? First on the list? That's the answer. It's because it's higher up. Okay. All right. Can zinc replace lead? Can zinc replace lead? Terry? Yes, very good. All right. Can copper replace barium? Can copper replace barium? Emily, what you think? Why not? That's exactly right. So that's what we're trying to get here. So let's look at our first example. All right, iron's coming to the dance all alone. And then this is the compound. What compound is that specifically? What kind of copper sulfate? Try again.
Aqueous solution.
It's copper 2. How do you know it's copper 2? Sulfate's 2 negative and the charges cancel. All right. Now, what? So here's the deal. Iron is by itself, so it's coming to the dance to try to get somebody. Who is iron going to try to... Stop. Who is iron going to try to replace? Sulfate? Why copper? It's a metal. Now, this is what you need to do. You need to look at this and determine, can iron replace copper? Absolutely. I've already said that twice.
What if it couldn't?
I'm going to show you one in just a second. So, can it swap? Yes. Now, be very careful with this. Notice what happened to copper. What happened to it? It's kicked out all alone. So he has nobody to dance with now. But here is the biggest thing that's going to get you. Is this a new compound? Yes. What must you do? New compound, check the charges. So write this in. New compound, check charges. All right, Hannah brought up a great point. We need to add one. We need to add an example here to show to look and see what would happen in this case. So this is what I want you to write down. Out to the right of this one. Yes, it's Al plus KNO3. All right, who's all alone? All right, Al is going to want to kick out who first of all? Why K? It's a metal. So we got to check and see if aluminum is cuter than potassium.
No, he's not.
No. So what do you do if it's not? This is all you have to do. Very, very simple. You'll love this. Write no reaction. That's it. No reaction. Very good. No attraction. I like that. No attraction, no reaction. No attraction, no reaction. All right. So that's all you have to do if it will not work. Okay? All right. Let's look at the next one.
Hamza, where's your umbrella? Why? It's raining.
Can please listen. Watch this. Do me a favor. You'll like this. Please put an X by number 2. We're going to skip it. Let's move on to 3. I need you to know this. This is very important. Please listen to what I'm fixing to tell you. When you see an acid, first of all, you need to recognize that it is an acid, and you will be able to do this by the end of this chapter. I'm telling you. But this is what you need to know. The hydrogen in an acid, H, is a cation. So, since H is acting like a cation, is that a metal or a nonmetal? That's a metal. So, H is going to be tried to replaced by who? By a metal in this case. H is going to be tried to replace by metal in this case. So let's look at what happens. Zinc metal is mixed with hydrochloric acid. What should happen to that piece of zinc in an acid? It should be dissolved, right? So that's exactly what happened. If we have enough time, we'll show you a little demo. All right. So we have zinc going to try to kick H out. What do we need to check to see if he can kick it out? See if it's higher than if zinc is higher on the list. Yes, it is higher. So H is going to be kicked out by itself. My first question is, why is there an H2 right there? I'm telling you, if you don't know your diatomics, you are going to be in big trouble. The second thing is Zn and Cl coming together a new compound? What must you do with new compounds? Check the charges. Zinc is always a what? Very good. Zinc is a 2+. Chlorine is a Cl-. So do you agree you get ZnCl2? After you do that, you just need to balance it. Okay. Any questions on this? What am I trying to get you to know about this? H acts as a cation. That's what I'm getting you to try to know. Yeah, you have to know that one. Do what? What do you mean? Let me show you this. What if, please watch, what if you try to do this? What if you try to make Zn and H come together? How will you know you didn't do it right? Every time you write a new compound, what do? So if you know your charges, zinc is always a what? What group is hydrogen in? So what is the charge of group 1s? Can you make two positives come together? If you do this every time, you will catch your mistakes. The same thing with this next one I'm fixing to show you. All right, Cl. Notice Cl is out by itself. I'm going to do it wrong first. Don't do it this way. All right, Cl is going to try to kick Na out, and we're going to try to move it. So now Cl and Br are going to come together. This is why this is wrong. Every time you write a new compound, you check your charges. Cl is in group 17, so it's a -1. Br is in group 17, so it's a -1. So automatically you should recognize that this is wrong, correct? Why is that wrong? Two negatives can't come together. So if you do it wrong, what can you do? Just come back and swap it with the other one. Just do it the right way. Now, since Cl is by itself, look on your list. Which side is Cl on? Can you cross the sides? Stay on that side. Can Cl, and who's it going to try to replace? Can it? Is Cl above? Yes. So Cl is going to be there. Now, why is there a 2 beside bromine? It's a diatomic.
So is that, you know it's a diatomic if there's 2 diet?
But you have to know the 7 of them. You have to know those 7. You want to write them down there at the bottom? H2O2, N2, F2, Cl2, Br2, and I2. The gun and the bullet. Huh? H2, N2, O2, F2, Cl2, Br2, and I2. 7. Diatomics. All right. I have 2 more I want you to try. All right, just write this up by the single replacement out beside the very last example. I want you to try to write both of these reactions if they will work. Try to write both of these reactions if they will work. Write them down. Out to the right of the very last one on single replacement, above that line, right there. See if you can figure these out. This is what you're going to see on the test, just like this. You're going to have to recognize that this is a single replacement, then write the products, and then balance it.
What kind of test is this one?
Multiple choice and work it out. I think there's like 20 multiple choice, maybe like 10. Like the first 5 are like, just tell me the type of reaction. That's it. Then the next 5 are like, just balance it, and the last 5 are like this. You should very simply be able to do the types of reaction and balancing at a minimum. That should be easy. If you want to. What? Oh, no. I don't have enough time. How much time do I have left?
Are we going to have discussion classes Sunday?
I don't know. All right, let's finish these up. Now, what is F going to try to replace and why? Why?
Because it's an NI.
Very good. Will it? Yes. Is BA and F a new compound? What do you do? So we're going to have BA, F2, and then plus I. Is that right? Very good. I2. All right. The bottom one. CA and Fe2O3. What is CA going to try to replace? Why? They're metals. Will it? Yes. Is Ca and O a new compound? What do you do? Check your charges so you get CaO plus Fe. Would it be Fe2? No, why not? Is the top one balanced? 2 Fs, 2 Fs. 1 BA, 1 BA, 2 Is, 2 Is. You're good. Yes, I just wanted you to try. Okay. Hang on one second. Ca1, Ca1. Fe. So how do I balance that? 2 right there. How many O's? 3. So put a 3 here and you're done. Yeah, oh, absolutely. Anytime you do a reaction, you have to balance it. Yes. Forever.